5.1a is simplifying trigonomic expressions, and this today is part 1. You need to know all your reciprocal identities and your quotient identities, and because you're going to need to use those today. And you need to also note it that every single term can be written in terms of sine or cosine, which is one of the strategies we're going to use today. Recall back to geometry in Algebra 2, the equation of a circle is listed below. This h value and this k value is the center of the circle, over h up k. So that's the center of the circle, and the r value is the radius, and taking the radius and squaring it. Now, if we think about the unit circle we can put on a coordinate plane, and the center of the circle is at 0, 0. So if I replace the h and the k with 0, 0, and we also know the radius of the unit circle is equal to 1. And we got that from when we developed the unit circle. We said this is x, this is y, and the radius was 1. So we could replace the r with a 1. Now if I simplify that, I have x squared plus y squared equals 1 squared. And you don't have to write this down, it's not on your note sheet. And, or just 1. And also think back to trig. We know x represents the cosine function, and y represents the sine function. So I could actually write this as cosine squared plus sine squared equals 1. And this right here is what we're calling the Pythagorean identity. Now, from that Pythagorean identity, we can develop 2 others, and I'll show you how you get those. But you need to have this memorized, and the first thing you should do when you're doing worksheets or your test is write that equation down. The next thing you will do is then develop this equation and this equation. But before I go into that, let's look at that sine squared plus cosine squared equals 1. I can rearrange these equations by simply adding or subtracting. So I could subtract the cosine squared to both sides, and then I will have solved for sine squared, like this. So I can take my sine squared, and I could replace it with this, or if I have this, I can replace it with the sine squared. Likewise, I could subtract the sine squared to both sides. And if I did that, I would then have cosine squared is equal to 1 minus sine squared. Okay, it's another way I can rearrange this. There are more ways as well. I could subtract the 1, subtract the cosine, subtract the 1, subtract the sine. There's several ways that you can rearrange that. Just know that they all mean the same thing. They just look differently. Okay, now we're going to develop those other 2 equations that we had listed on the paper. And those were in terms of secant, cosecant, and cotangent. And how we're going to do that, and tangent. And how we're going to do that is we're going to take this first equation, and the first time around, I'm going to divide this everything by sine squared. And I can do that because my fraction is still in equilibrium if I divide everything by the same thing. And now I'm just going to simplify. So if you take a look here, this actually simplifies to 1. And the reason being is this. We know 2 over 2, both are divisible by 1, that equals 1. Also, we could do the same thing with x squared over x squared. That's equal to 1 as well. Well, what the sine squared means is this just means it's really sine of x times itself 2 times. Okay, we put the exponent inside here between the sine and the x so it looks cleaner, but these mean the same thing. And from this, we know that this just means sine of x times itself 2 times, like this. Okay, well, if we took that and divided it by itself, sine of x times sine of x, what you're going to notice, these simplify to 1, these simplify to 1. We're left with 1 over 1, which is just 1. Now I'm going to do the same thing with this part. Well, we know that cosine over sine is equal to cotangent. And because both of these are squared, this will also be squared. If those both weren't squared, then we couldn't do this. And we'll talk about how we simplify that later. This right here, we know 1 over sine is cosecant. And because that's squared, we can just square it. And this here is the second equation that we have written down from that first slide. Now, I could do the same thing here, but this time I could divide everything by the cosine squared. and then simplify. And if I do that, I have sine over cosine, which is tangent, and both of them are squared, so I could write that as tangent squared. Here, I have the cosine squared on the top and the bottom. That simplifies to 1. And here, I have a reciprocal function, which is equal to secant squared. And this is a way to develop my third Pythagorean identity. So as long as you remember the first one, sine squared plus cosine squared equals 1, pretty easy, it's like a Pythagorean theorem, you can then develop the other two so you don't have to memorize all of them. And that's what you should do for your test. So here are the three identities. Again, you truly just have to memorize that one because you can develop the other two. And what we're going to do now is we're going to start simplifying trig identities. And these are some of the strategies we're going to use. And I sort of put these grouped because the top two are the two that you use the most often and the two that we're going to work with today. And it says look for any trig function that is squared and a plus or a negative 1, plus or minus 1. And if that's the case, we're going to use one of the trig identities that we just developed from that previous slide. The next strategy is to put everything in terms of sine or cosine. So using the reciprocal functions and the quotient functions to put everything in terms of sine or cosine. The other three right here, we will do tomorrow. Okay, so here's how it works. If you take a look at problem number 1, you're going to notice you have a trig function that is squared and you also have a plus 1. What you should do to that, anytime you have that plus or minus 1 and a trig function squared, is write down the appropriate identity. So you are going to go to the front of your page and you're going to find the identity that has a tangent squared. And what you see is this: tangent squared plus 1 equals secant squared. And if you have to rearrange this to get this to match this exactly, you will do so. But you will notice it already matches exactly. And therefore that, what I have in the red box on the left and the red box on the right, is equivalent to this. So this is equal to secant squared. That is my answer for the first one. If you look at the next one, we do have trig functions squared. We have 2 of them, but there's no 1 added or subtracted to the function. So for that reason, we cannot use one of the Pythagorean identities. But what we should also notice is that sine over cosine is equal to tangent. So if I have sine squared, it just means sine of x times sine of x over cosine squared, or cosine of x times cosine of x. Well, here's one tangent, and here's another tangent. So tangent times tangent is just tangent squared. But again, it's very important that you put the squared inside there, because to make it look cleaner rather than writing it like this. That's equivalent, but it looks messy. But a common mistake and what you cannot do, because it's not the same, is this. Because what this means is it means tangent and the x is squared, so it's x times x to follow. And it's totally different, so you cannot do that. All right, the last one down here, you will notice we have a tangent. If we write that in terms of sine and cosine, we could write that as sine of x over the cosine of x. And that is being multiplied by the cosine of x. Okay, there's multiplication there. If you don't see a sign, it's multiplication. Because I'm dealing with fractions on the left, I want to make sure I have a fraction on the right as well. And just a reminder, when we multiply fractions, we just push everything together. And so we would have sine of x times cosine of x on the top and a cosine of x on the bottom. And look what happens. The cosines simplify away to 1s, and what this is equal to is just the sine of x. And that's our answer for that one. So here's 3 examples using 3 different ideas that we're going to focus on today. So let's take a look at the first one. Using the 2 strategies that we're focusing on, you will notice we do have a trig function that is squared, but there is no 1 that's added or subtracted to this function. So therefore, we cannot use the identities. Instead, what we need to do is put everything in terms of sine or cosine. This we can write as 1 over sine of x. And then I'll just recopy the first part. But while I do that, I'm going to put it over 1 because I want to have 2 fractions instead of just 1. And if I extend this fraction like this, you will notice that there's a sign on the bottom and there's 2 signs on top because this means sine of x times sine of x. One of those can simplify away, which will leave us with our answer of sine of x. Now, if you take a look at the bottom one, you are going to notice that there is multiple trig functions that are squared, and the one on the bottom has a 1 added or subtracted to it. Okay, so that one right there is the one that we're going to work with. Now, first of all, I want to tell you this is the most common mistake that is seen. People say, oh, the sine squareds cancel away. Yeah, my answer's 1. No, it's not 1. Those do not simplify away. Do not do that because we have subtraction here. And anytime you have addition or subtraction, you truly have a quantity there and there should be parentheses. There's imaginary parentheses. So we have to take this quantity that's down here and we have to replace it with one of our Pythagorean identities. So you're going to go look at your Pythagorean identities and write down the only one that has a sine squared in it. And that is sine squared plus cosine squared equals 1. You're now going to rearrange it so it looks exactly like what I have in the box. And note the 1 is positive. The 1 is positive. The 1 is also positive here. Don't move it, okay? You can only move the other 2. The 1 is grouped with a sign, so we want to subtract the sign to both sides. That's negative, okay? That one we want to move. Every time you move something, the sign is going to change. What we now have is 1 minus sine squared of x. What I have in the box here and what I have right here is equivalent. And because they're equivalent, and this is also equivalent to that, I can use substitution and replace that with cosine squared. And in the numerator, I have sine squared. And now, because they're both squared, I have sine over cosine, which is equal to tangent. And because they're both squared, I'm allowed to do this, and I will just square my tangent. Again, if they weren't both squared, you could not do that. We'll talk about how we're going to work with that later. Now, what I want you to do is I want you to use those 2 strategies that we just talked about and try number 7. Pause the video, and then you can come back if you need help, and once you have the answer. The first thing you should do is replace this. Again, you cannot simplify these away because that bottom one right there is connected as a quantity with the subtraction sign. So I'm going to look at my Pythagorean identities and write down the only one that has cosine squared in it, and it is this. Because the 1 is positive, I will not move it. Because the cosine is negative, I will move it. So I'm going to move that to the other side. And what I now have is sine squared is equal to 1 minus cosine squared. And what I have boxed here in red and what I boxed here in red is the same, which is also the same as this. So I'm going to replace that with sine squared. The cosine squared is on the top. Cosine over sine, because they're both squared, I can then call this cotangent squared. And that's what you should have for the answer. Okay, now try number 5, using the same strategies. Pause the video. If you get stuck, you can bring it back, but try to work as much as you can on your own. You got to start down here. This is a quantity. And my identity that has cosecant squared in it is tangent squared plus 1 equals secant squared. If I rearrange this to keep my 1 positive, I do not move my 1. What I do need to move is my secant because that's negative. So when I move my secant, I then have tangent squared of x plus 1 minus secant squared of x is equal to 0. Now, what I have right here and right here is what I'm looking for. So I need to take my tangent and I need to move it to the other side so that I've isolated what I've highlighted. I now have 1 minus secant squared x is equal to negative tangent squared x. Don't lose your negative. But now that this is the same as this, I can replace it with that tangent squared, negative tangent squared. So on the top I have tangent squared. On the bottom I have a negative tangent squared. This tangent squared and this tangent squared simplify away. And what I'm left with is a negative 1. And there's my answer. The next one you should try is number 9. So again, pause the video. In this problem, you have a trig function with a plus or minus 1, trig function squared, sorry, with a plus or minus 1 in both of these. So you have to replace both the numerator and the denominator. So you will have to take the equation sine squared plus cosine squared equals 1, rearrange it twice, once to match the top, the second time to match the bottom. So go ahead and do that if you haven't already. My top one, my cosine is positive, so I cannot touch my cosine. My 1 is negative, that's what I want to move over. So I will subtract 1. I then have the cosine squared x minus 1, but in addition to that, I have that sine squared x. And that sine squared x, I need to move to the other side. So I am going to subtract that. So then I have cosine squared x minus 1 is equal to negative sine squared x. Now this is exactly the same as this, which I can then replace with this. Doing the same with the bottom, and if you didn't get the top one right, you should pause the video and do the bottom to make sure you know how to do it. The sine is positive, I don't touch that. My 1 is negative, so I do move that. So I have sine squared of x minus 1, plus cosine squared of x, and that's equal to 0. Now, I need to subtract my cosine of squared x, because that is not on my problem. And when I do, I have my sine squared x minus 1, and that is equal to negative cosine squared x. This here is the same as this here, which is the same as this, so I will replace the denominator with this. I now know that a negative divided by negative is a positive. And sine over cosine is tangent, and because these are both squared, it's just going to be tangent squared. And there's my answer for that one. Now I want you to try 5.1a worksheet, the front side. So whatever we didn't already complete with the front side, I want you to try to finish. And once you're done with that, you can then watch the next video. And do not submit this into Schoology until you've completed the whole worksheet, so you have to watch the next video.